All right. Hello, hello. Good morning, good afternoon, whenever you're watching this. We are in the 420 student packet. We're going to continue our talk on visual distributions, visual data, and the types of distributions and then what that means for our measures of center. So, yesterday we mentioned symmetric versus normal data. And this is when our data is nice and centered. We get this nice bell curve, so we call that normal or symmetric because both sides are the same. When we have something symmetric and nice and pretty and even like this, we use the mean as an appropriate choice for describing a typical value for the distribution because it represents the middle of the data. So for symmetric, we use the mean to represent the middle. So when we have this nice pretty curve, we use the mean because it is right smack dab in the middle of our data. Now, non-symmetrical, when we have this going on, we are going to use the median as an appropriate choice for the center. Now, what's important today is understanding the reason why we use the median for the center in this case. So, medians are strong. They stay in the center and they do not move. So, wherever your bulk of data is, it's going to find that middle and it's going to stay right there. Means are weak and they get pulled towards the outliers. So this image right here should look familiar. I've showed this one before. So remember, when we have outliers or these numbers that are like far away from the rest of our data, or just like either larger or smaller than where the bulk of our data is, it pulls that average, it pulls that mean away. The mean gets distracted, it's weak, it's going to follow the outlier. The median is going to stay put and be like, what the heck are you doing? Why are you leaving? So let's think back. So when we were calculating our measures of center, Ms. Zach had 6 tests. She got a 70, an 85, a 76, an 80, and an 85, and a 30. Well, let's say, right now, her average is probably going to be between 70 and 80, right? Because that's where her test scores are. If we have this average of 30, it's going to bring our average down because that is a lot lower. That's our outlier. So if we think about it and we graphed it, well, here's the bulk of our data at 70 to 90. 30 is going to be way down here. So now if we look at our graph, it's going to be skewed to the left. And what did we say this really low number was going to do to our average? It was going to bring it down. So our average, our mean, is going to go from being here in the middle to being somewhere a lot lower versus our median will be somewhere here in the middle between 70 and 80. So when we have this lower outlier or when we're skewed to the left, it's going to pull our mean to the left. So, number one, this graph right here and this graph are skewed to the left because remember our tail is pointing to the left. My larger number is over here and then it gets smaller and spread out this way. So it's left skewed. Same, larger numbers are over here. That's where the bulk of my data is. And then it gets spread out thin to the left. So when we have left skewed data, again, my mean is going to be pulled that way because these little outliers over here, those smaller numbers, are going to bring that calculation down. So if it's left skewed, it pulls mean to the left, meaning my mean is going to be a smaller number than my median. So my mean is going to be smaller than the median. So again, when we have left skewed, it pulls my mean to the left, making it smaller. And then the opposite happens when we have right skewed data. So here, again, now we have our bulk of our data here, and then it spreads out really thin to the right, so my tail's pointing to the right. Same, bulk of my data is here, spreads thin over here, so again pointing to the right. So for right skewed data, what's going to happen now is the opposite. Now we have these outliers that are way larger, so it's going to pull my mean, because it's weak, it's going to pull my mean larger, where my median is going to stay nice and strong and stay in the middle. So my mean becomes now larger, because now it's to the right, which is going to be larger numbers than the median. So now my mean is larger than the median. That works. Okay? And that's the key thing for today. So again, symmetric data, when we have this nice pretty bell curve, mean is fine to use because it's right smack dab in the middle, and our mean and median is going to be probably just about the same number. Now again, left skewed data, so when we have that tail pointing to the left, it's going to drag my mean to the left. It's really, really important here to remember that the mean is weak. The mean is weak, so it's going to get pulled. The median is going to be strong and stay there. And so when we have that mean being pulled to the left, it becomes smaller. When we have that right skewed data, we have those outliers that are bigger, so it's going to be pulled to the right. Again, right skewed pulls it to the right where our larger numbers are. So my mean becomes larger than my median. So let's check this one out. So I'm just going to jump down to the question here. I see I have a dot plot. I want to know, number one, which way is the data skewed? So take a peek at it. See if you can figure out which way is this data skewed. Data's right skewed. We have the bulk of our data right here, and then it thins out way over here, which is to the right. My tail points to the right, so we would say this is right skewed. Okay, so what does this mean about the mean? If I am right skewed, is my mean going to be less than or greater than the median? Take a second and think about it. Scroll back up if you need to. All right, so again, when it's right skewed, the mean is weak, so it's going to pull my mean to the right. So my median is going to be somewhere where the bulk of my numbers are, and then it's going to pull my mean to the right, so my mean is going to be larger than the median. Again, my median is going to be where the bulk of my data is, the middle. My mean is going to get pulled because it's weak. And it's going to get pulled the direction that it's skewed. So it's right skewed, so it's going to get pulled to the right where my larger numbers are. All right, go ahead and try this one. Tell me what direction is it skewed, and then is my mean less than or greater than the median? Go ahead, pause me, try it, look back at your notes, look at the example above, and then come back after you give it a shot. All right, so this one, I see my bulk of my data is up here, and then it thins out over here to the left. So my data is left skewed because my tail points to the left, so it's left skewed. Okay, now what does this mean for the mean and the median? So my median is going to be somewhere in the bulk of my data. I'm just going to say right there. Remember, the mean is going to be weak and get pulled the same direction as my tail. So my tail is to the left, so that means my mean is going to be pulled to the left. Are those numbers smaller or larger than the median? They're they're smaller. As we move to the left, we're getting smaller towards 0. So my mean is going to be less than my median. So first things first, again, figure out what direction it's skewed, left skewed or right skewed. And then when it comes to figuring out if the mean is less than or greater than, remember, whatever way the skew is, that's the way the mean gets pulled. Again, the mean is weak, so it's going to get pulled with the skew, where the median stays the same. All right, I want you to go ahead and try these 4 problems. You have 4 different graphs, and I want to know what direction is it skewed? Is the mean higher or lower than the median? Same all the way down. And then I'm going to ask you questions. Well, what do you think the most appropriate measure of center is? So give these a shot and good luck. Message me when you have finished so I can check your answers and see how you did.